In this video, we will see how to use GeoGebra to conduct a hypothesis test for the population proportion. So in section 3.5.3, a hypothesis test was performed to test which was correct. The campaign managers claimed that more than 50% of voters supported his candidate, Deborah Toohey, or her opponents claimed that less than 50% of voters supported her. And we use the following hypotheses. The null, H0, is that P is 0.5. The alternative is that P is not 0.5. So we have a random sample of 500 likely voters. 260 of them supported Toohey. Perform the hypothesis test using GeoGebra. So the first thing we'll do is go to the statistics panel and select the z-test of a proportion. So we put in the null value that we see above, 0.5. Then we select the type of test. This is a two-tailed test. Then we put in the number of successes, that is the number of people that have that characteristic, 260. And then we have a sample size of 500. So if we do that in GeoGebra, we click on the toggle, we go to the three dots, we open up the probability calculator, we go to statistics, and we see the z-test of a proportion. This is the one we want. So we have our null value of 0.5, and we have our two-tailed test. We put in our 260, our 500 for the sample size, and below we see the results from our test. So we see a z-score of 0.8944 and a p-value of 0.3711. So we come back to the problem, and we're going to label the test statistic and shade the area corresponding to the p-value. So in the null distribution, this is the standard normal z-distribution. We have 0 in the middle, and then our test statistic is the z-score, which GeoGebra is telling us is 0.8944. So that would be about right here, not quite to the inflection point. So that's our z-score. The p-value will be the area under the null distribution that's as extreme or more extreme than our test statistic in favor of the alternative. Since the alternative is a two-tailed test, we also have values over here that would also be as strong or stronger against the null. So we have to shade on both sides of the distribution. So we'll label the z-score and then we'll label the p-value. Like that.